Hi, my name is Yuling Liu. I'm an incoming junior student majoring in computer science at University of Michigan. I'm working with Professor Michael Wellman and the Strategic Reasoning Group this summer for the SURE program. My project is mainly based on an online interface called EGTAOline, which we use to do the game theory, simulation, and analysis. Next, I will show you guys what I have done for the last 3 months.
Alright, let's begin. In my point of view, my research in this summer can be split into two parts. The first part is centered on market maker stuff, and the second part is mainly about automating the game analysis on EGTAOline. At the very beginning, I would like to introduce our online interface. You may ask, why do we use this? Because our research focus is simulation-based games. We use this testbed to simulate games and do analysis. Based on the result, we can see the best responses for both background traders and market maker in one subgame when regret approximates 0. Here, when I say subgame, I mean a complete subgame, which is a configuration of roles and strategies for which we have all the profiles. And regret means the maximum additional payoff a player can get by switching to another strategy. If it's 0, then it's in the equilibrium. If it's some small number above 0, we want to continue getting data for additional profiles by scheduling DPR deviation scheduler until the game has reached a state where all regret is either exact 0 or something much greater than 0. In the first part of my research, I created two environments. It is environment 4 and environment 5. As we can see here, within each environment, I have background traders with market makers and background traders without market makers. Because we know that usually when market maker gets involved in the stock market, the total surplus and the efficiency for that market will be increased. So we want to see how the same market behaves with and without market makers. Also, there's one comparison between these two environments. When we go into the DPR scheduler for both environments, you can see the only difference for the parameter I set is the re-entry rate for the market maker. I set it to be 0.0005 for environment 4, and I set it to 0.005 for environment 5, which is 10 times faster. When I did the analysis, it turns out the best response of background traders and market makers are the same for both environments when it reaches the equilibrium. You may wonder how I did the analysis. I took the game JSON file as input and ran two Python scripts. One Python script called reductions.py and the other called analysis-script.py. The first script is used to reduce the game from 67 players to 7 players, consists of 6 background traders and 1 market maker. The purpose of reducing the game is because if we want to analyze the full game, it will take too long to run the analysis script. We pick this reduced count because it is one of the best estimates if we want to save time to get the result. The analysis script starts by going through the game to find all maximum complete subgames. For each subgame, it performs a search for equilibrium and generates the output. So, this is the form of the output file. As we can see here, for subgame 2, the regret is 0, and there's one Nash equilibrium. Here, we can see the best response for both background traders and market makers. However, during this stage, I got the output file after I manually run the Python script in the terminal, and I have to wait until it is done. So here comes the second part of my research. I worked with another graduate student from School of Information. Our task is to automate the process of analysis on EGTAOline. In this part, I mainly used Ruby on Rails 2 programming and also wrote the PBS script, which will automatically execute the command line in Flux HPC cluster. I will show you guys the great benefit of doing this. I can first go to the game object, and we can pick one game. For example, environment 4 with market maker. So, if I click this button, you will see a page that can set arguments for both Python script that I would use to do the analysis. You can set the running time and also allocate the memory for that. This is the reduce count for the reduction.py, and this is a parameter you can change for analysis script. If you go back and click this button, you can see all the output file listed here, and there is time here represents the time that when you order it, so that I can do the comparison for any files I want. I can click it, then it will be downloaded to your local computer. This is my research of the summer. Thanks for watching.